Yeah, and what did you mean by this? So if you can produce your own food, you don't have a brain.
Yeah. But this is quite core to the whole thing. If you actually look at all across everything that lives, you can broadly divide it into plants and animals.
Yeah.
And animals have brains and nervous systems, and plants don't, because plants make their own food.
Okay.
And that's essentially the evolutionary rationale that's been applied to this. And by all means, have a look, check it for yourself, ask your AI. But if you can photosynthesize your own food, then you don't need to move to get food. Also, animals, on the other hand, not only do they need to go and get food by eating something like a plant, but they need to move away so that they don't become lunch. And so the whole purpose of movement and starting to monitor the environment to get food forms the basis of what you then need as a nervous system. And animals increasingly do that in increasing complexity over time and through the species. And it's fascinating, but it's also quite core just to come back to, well, what is a brain for? And the deal, I think an important part of it is, it's not just for us to sit around and feel good and have a massage indefinitely for 3 weeks on the trot, because it just keeps feeling good. There is a kind of built into the system is this need for movement, this need to access energy and then to circulate the energy and keep that cycle going. Plants do it their own way and animals do it their own way.
That's interesting. I'm just thinking with the plants, so it's more about the evolutionary reason behind it is for having a brain is to seek food rather than, you said about becoming lunch.
Or not become food.
Not becoming
both.
food. Yeah.
So both seeking food and whilst you're seeking food, to make sure you don't become someone else's food.
So plants obviously are food. But they just haven't got to a stage where that matters to them.
They're pretty chilled out about things.
Okay. That makes sense. Interesting.
And that's part of the thing of, the whole responding to the environment. Plants do respond to the environment, but not with nervous systems. And nervous systems have their own kind of machinery and their own kind of configuration, their way of going about responding to the environment, which involves things like fear, movement, perceiving the environment.
Okay, so nervous system, if you have a nervous system, if you don't, let me get this right, if you don't have a nervous system, you're quite chill, but you have to eat light.
You have to convert light into the energy source.
Okay.
Which is what plants do.
That's a bit of a trade-off there.
It's an important trade-off, absolutely, for all biological beings.
Okay.
Another point to mention off of this is once we're started to think about what nervous systems and brains do overall, not everything with a brain has the same level of function or the same output that a brain can do. So humans reasonably arguably, can do quite fascinating things with our brains, like make a souffle, make a video and upload it to YouTube, drive a bus, just picking things I'm seeing outside now. There's so many things that we can do. And that complexity comes into all the different ways the brain is interacting before an action comes out. And I think another really important thing is to consider that the brain is overwhelmingly an organ of inhibition.
Okay.
Which seems counterintuitive.
Which means to stop you doing things, right?
Not so much stop, but control. To choose options judiciously. So essentially, as you go to simpler brain systems, the number of choices of what they can do in the environment is limited. You can either run away, there's essentially fight and flight responses, which when we have problematic brain systems going on, we revert to those, possibly in an unhealthy way all day long and all night long and don't get any sleep, and that worsens. But so when you go to a very simplified model of things, you can either have the fight and flight response, there might be fear, anger, attack. There's not many things you can do with very simplified movement patterns. And when you look at early fish and those kinds of nervous systems, that's what they're exhibiting. There's not much more than that.
Okay, so is evolution complicating our lives and our brains?
I'll replace the term complicating. how about fascinating?
Yeah.
And let's not put value judgment on it negatively. Why not put a positive value judgment on it? It is making our lives more fascinating because of the sheer level of complexity and options that we have. And those options only come about from inhibition. So the brain is able to take that initial urge, whether it's anger, fear, response, hunger even, and just say, well, let's hang fire.
Yeah.
Maybe not now. Let's convert this in another way.
Yeah.
Even the way we move our bodies is largely inhibitory. You think that, okay, when you're pointing is, am I just going to tell my nerves to move this, just this finger? Actually, as well as this finger, there's everything else inhibited. So all these fingers are inhibited. So everything else is in balance. So everything that I'm trying to do, there's also so many other things that the brain is inhibiting from not happening at the same time.
That's interesting. And the brain doesn't work like that in the same way as inhibiting. It kind of chooses the path it goes down. Or is that too simple?
We get to choose gradually over time, and we get to learn and practice those and get better at them. And whilst we're trying them, we might find something that works a little bit better.
Okay.
And that those nuances come from slight different changes in inhibition, all of which takes time and learning. And that feeds back into, you'll find that people who are very effective in most things are not the ones that bolt straight out and do the first thing that they're thinking of.
Yeah.
The more measured response, the more trained response, things that have put the time in to use that inhibition come out with better outcomes.
Yeah. Is it a bit like domesticating dogs, how now they can stop barking if you train them, and
how many other things can they do after that?
Quite a lot, actually.
Exactly.
Yeah
Very much so. That's a good application of that straight away. And it applies across the board, see whichever context it fits for you in, but the more you lean into the power of the brain being an inhibitory organ, it allows you more options of what you can do with different levels of control. It's not just about what the brain can do, it's just what is the brain not doing, what is it not selecting to do. That opens up more doors for you.
Now
we're going to come on to, I'm going to try and not get too preachy about this. Dopamine hits is a phrase that's used so ubiquitously. One way of thinking about it is that let's take an oversimplification that is accepted. Generally, if you listen to any podcast, any pop psychology interview, people will be talking about the fact that if you feel good, if you've watched something that you enjoyed, you got a dopamine hit. And there's an implication there that dopamine is just doing that. But that's simply not true. A way of looking at dopamine, as with most other neurotransmitters, and even hormones if you like, is that they're like currency in the body. And that currency can be spent in different circuits to get different things. So in one particular part of a network, dopamine is used for things like reward and motivation, but it's also really, really important for smooth movement control and not having a tremor, and really, really important in controlling breast milk regulation.
Quite varied things there.
Really varied depending on where it's used in the body. So this oversimplification of I got a dopamine hit, whilst it's kind of trying to get at something, that oversimplification could lend itself into problems. And when people start thinking, I could microdose a bit of this to up my dopamine and I'll feel better without being addicted to something, that's an oversimplification and a problem. Because that's not what's happening. At the very worst end of the situation, when dopamine systems go completely low and awry, an example of that is Parkinson's disease. And at the other end, the dopamine hypothesis as it relates to diseases like schizophrenia, we use dopamine blocking drugs to treat those, and those are termed antipsychotics. Now, you can see that this is very, very different. There's so much scope of what dopamine does that feeling good or enjoying something doesn't neatly, there's so much more going on than that.
Would it be fair to say on some level it chains things together, actions or thoughts?
It is, so a lot of kind of attaching what we call salience, meaning, helping in memory formation, those kinds of things. But it's not just dopamine.
It's not just those things.
Because you'll be using so much of glutamate, which is an excitatory neurotransmitter, GABA as well, to say, like we said, that whilst you're attaching memory to some things, let's say I'm attaching memory to this conversation here, today, in this room with you, but I'm not attaching it to my memory of this particular bookshelf today.
Yeah.
That's been inhibited. So,
Okay.
so I've had to focus it, but so many things are working at the same time.
Yeah.
It's not just dopamine,
I see.
and it's not
Okay.
just hits of dopamine.
Okay. I've got you. For me, like, even just talking experientially, I see sort of dopamine in a very simplistic way as a feeling of lack sometimes. So when you talk about people talk about dopamine hits, that's perhaps another way that it's contrary to that, counter to what they've been. Yeah.
I mean, more interest. There's some experiments which really quite fascinating. Link it more to the actual initiation of the behavior leading to a reward rather than the reward. That actually dopamine is much more in starting the motivation to get something, and actually once you get the reward, it's a whole bunch of other things that are happening at the same time, like blood perfusion increasing, noradrenaline, serotonin. It's a big flux of things, and that's why this oversimplification is a bit of a bee in my bonnet.
Well, I think in some ways we both agree on something. Like, I like to expand the understanding in a very experiential, and not having it narrowed down to like an oversimplification. And it's a similar way for you that it's much more complicated than is talked about in pop psychology.
And also just being aware of some of the problems that can lend itself into thinking. So then some of the hacks come along. Well, you can just increase your dopamine like this.
Yeah.
Well, there's increasing your dopamine where in your gut to help it move quicker, and in your immune cells where it's also regulating function there. Which there's so much more. So increasing dopamine via maybe trying to take supplements that are going to lead to it breaking down in a certain way. It's now so many jumps away from the actual real situation. I'll get off my soapbox on that one. And another thing that is slightly more fun to think about as processes that go on is what happens when we make a mistake.
When we make a mistake.
And we recognise we've made a mistake.
Okay. Yep.
So have you had that internal cursing yourself?
Yeah.
No bad language on camera.
Sometimes it feels like a drop, like that kind of thing. Like,
Exactly.
What have I done?
And how quick is it?
Very quick.
Yeah. So it's actually somewhere in the region of 300 to 500 milliseconds, and it has been termed the P450 response, or the 450 response.
Okay.
And it's reliably across a lot of experiments in EEGs where they measure through scalp electrodes. They measure some of the signals that way. And there's this reliable thing. Usually at the front, participants have made an error, and they're internally thinking, "Oh, that messed that up." That comes at that time frame, kind of about that early mark, and it's so consistent across different experiments. It's quite interesting. Now, what is also quite interesting is, why is it bad? And this feeds back into what we were saying of what the brain is there for in the first place. If the brain is there to look at the environment and make sure that you can go get food and make sure you're not food for something else, then you need to just keep checking and making predictions. Like, that's something new in the environment. I'm predicting that that's safe. Hold on, that's moved and that's an environment. I'm predicting that that's a threat. And those predictions need to be, the learning behind those predictions need to be quite solid, because you'll die or get eaten. And that's why having that kind of prediction error and the way it's quite reliably detected just keeps turning up in people's brains.
Oh, okay. So something changes at that time. So that's how long it takes.
Yeah,
It's
so
named after the time it takes.
400, roughly between 300, so it's early, 300 and 500 milliseconds after a stimulus has been, after something has been observed as, messed that up. And it stays, it lingers. So it's only happening in a certain area where it's being recorded on the scalp. The rest of the brain continues to do its own thing, but this is very focal, where it seems to be ruminating and keeping that going for longer. And it's interesting, in anxiety and depressive states, this has been shown to be extended for longer. So that there's actual localized change in how the electrical signaling is happening.
Okay. So when you ruminate or something kind of gets stuck,
If something's stuck in it,
that's showing up. Yeah.
And it has its uses, because the whole point is that if you've made an error about your environment,
Yeah.
then you want to learn from that error.
Yeah.
So it needs to stay there. And as we're saying, so you need to keep that there as something new to, like it's still peskily just there for you to pay attention to.
So if I ask you a couple of things, will you tell me if that is oversimplifying or if there's some truth in that?
I mean, we're all going to be oversimplifying something. Yeah, let's give it a go, but why not?
So is it like a Control-Alt-Delete for brain?
Oof, great question.
A reset of some sort?
The P450 itself, no.
Okay.
It's kind of the opposite.
Okay.
It's kind of like it crashing and staying stuck, or the turny circle of doom on a Mac.
Okay. Is it a spike in some areas or some energy?
Well, it is a different way of the electrical signal picked up around the frontal regions is different, so it's polarized in a different way. When you call that a spike, that changes depending on where you put the electrode, but we don't need to get into the nuances of that.
Am I right in thinking that there's a certain judgment or analysis energy there that's looking for what I did wrong or what the change is, and that's the protecting mechanism? Yeah. I can really associate with that feeling, that experience of being like a lens comes on myself and I'm like, oh, what have I done?
What have I done? Yeah, exactly. I've messed that might up.
Or like, just a scattiness. Okay. Yeah.
So that internal critic, we know when they start.
And I like, when you have that kind of energy of anxiety, I often feel an inhibition, and it will stay in rumination.
Yeah.
So there's a lot of energy to like panic, but it just stays in. I look calm from the outside, probably.
Yeah, it's just circling around, around.
Yeah, I'm just 404ing. Exactly. like a 440 page. Error page response.
Like nothing's coming up. Nothing's coming up at all. We tried it again.
Can't find what to do.
Refresh. I'll come to the final one, which I think is really fascinating. There's this concept of neural habituation. Sounds very fancy, but it's something we've all experienced.
Yeah.
And I'll phrase it in the geeky scientific language first. That a neuron or set of neurons exposed to the same stimulus will have a reduced response output over time. That sounds really boring. Basically, if the same thing happens over and over again, you'll get bored of it.
Yeah. You can get bored of it.
That's it. And it's built in. It's locked into how your body physiology works.
Like when we're on our phones, we can get kind of addicted, kind of stuck into that. Those, if I say hits, I don't mean dopamine. I mean like stimulation.
Yeah.
But even when you get hungry enough, even that, you can put that down. So something takes over then.
Yeah. Because now the novelty, the signal for the hunger has grown so big. It is now a new novel stimulus in the environment, which is overpowered you looking at your phone.
Okay. So something in there is going,
until,
give me attention.
Yeah. Until you eat.
Yeah.
And then enough signals going the other way that you're now bored of that.
Yeah.
And then the next thing comes along. Okay. And this is quite interesting as it ties back into how much control we then have or try to take in a situation. Because if you're constantly just pinballing around stimulus to stimulus, you start to divest and give away your choice in the matter.
Yeah. Interesting.
That's where meditation, wellness, doing things where you take a moment just to turn it off and have a bit more control between the stimulus and the response. That's where you get to be you.
Well, that's when the road of excess leads to the palace of wisdom.
Right, okay.
Great quote. When you sort of realise those bad habits and you can have too much of a bad thing. I think if you're just pinballing between McDonald's and doom scrolling, you're not going to have a good time.
No,
it's not going to get you anywhere.
Outside of that recipe.
Yeah. So that kind of excess doesn't lead to palace of wisdom, but I think given enough time and a certain human nature, you will probably come out of those ruts.
Hopefully, yeah. Hopefully. That's a pretty bad rut to get out from.
Yeah.
Another important angle on the neural habituation, or how we get bored, essentially, let's just call it that rather than a fancy term, is of chucking miracles in the bin.
Okay.
Right now, miracle, I know, is a very loaded term and can get people's backs up. Are we heading into religious, spiritual? We'll try not to, upset too many people. But what if we redefine what a miracle is? So a miracle, essentially, we could, for the purposes of what we're going to talk about now, something that statistically is so unlikely that it might as well be impossible. Does it have to be impossible? Or does it just need to be seemingly impossible? Would you agree with that?
Yeah.
And have you had the experience in the past where you were on the other side of something, where you were just hoping, maybe even praying, pleading, this is not going to happen, this is impossible, but please, please, the universe, God, entropy, whatever phrase you want to pop in there, please make this happen, please. And then it did happen, right? Maybe once, twice, maybe a few times. Exactly. So with all of these weird, statistically unlikely things to happen, when they do happen, the slightly sad thing is neural habituation kicks in. And so when neural habituation kicks in, what we were wishing and praying for the night before, we might enjoy for 10 minutes, if we're lucky, half a day, if we're really lucky, a week. And then 3 weeks later, chuck that in the bin. I'm at a new level of habituation now. And back to maybe wanting new things, desire and dissatisfaction. What else can I get? What is now new, novel in the environment that I can pay attention to? And that's fine, because it's going to lead you on to the next thing. However, what might be helpful is if you go back and look in the bin, look at all the things that were once miracles, were once things that you really, really wanted to happen, that you thought against the odds, it's not going to happen. And if it did, what would it be like? That would definitely be X, Y, Z, and how many times that's happened. And actually, once sifting through the miracles in the bin, it's quite a nice exercise to go through.
Well, it's a gratitude practice, perhaps, in a way. I like that.
So check out your bin.